yesterday we started learning how to solve systems of equations word problems. However, I discovered as we worked through some of the word problems that it wasn't necessarily the words that gave y'all trouble. Many of you are still struggling with elimination to begin with. So, I made up this worksheet of 10 elimination problems, and they are not the most basic kind. Like on the quiz Friday before the break, you had like the easiest elimination you can get. You didn't have to multiply by anything. They were ready to eliminate. And so I feel like maybe we didn't spend enough time on the harder ones. So that's what we're going to do today, and then we're going to move into word problems. Number 1, we have negative 8x plus 3y equals negative 5. And then our second equation is negative 16x plus 2y equals 18. Well, keep in mind, to eliminate a variable, to eliminate the x's or to eliminate the y's, you have to have the exact same number beside the variable, and it has to be opposite signs. One has to be negative, one has to be positive. So in this case, we have two problems. They're not both 16 and they're not both 8, and they're both negative. What would be nice, like if you were a magician and you wanted to change one of these numbers, what would you want to change it to? Right, it would be nice if this right here were a positive 16, correct? Because if it were a positive 16, it would just eliminate with the negative 16. Well, what can we do to turn a negative 8 into a positive 16? Multiply it by a negative 2. Because negative 2 times negative 8 is positive 16x. Negative 2 times 3y is negative 6y. And negative 2 times negative 5 is positive 10. Now, we have no need to change the bottom equation. We'll just rewrite it. Okay, so now that I see that I have one variable, and that variable has the exact same number beside it, but opposite signs, I'm ready to start the process of elimination. Okay, so I'm going to add the two equations together. 16 plus negative 16 is 0, so that eliminates. Negative 6y plus 2y is negative 4y. And then 10 plus 18 is 28. Now to solve for y, what do I do on both sides? Divide by negative 4. And so y equals negative 7. Once you find the y, though, you're not finished with the problem. To solve a system, you have to find the x value and the y value. How can we now find the x value? Right, you can plug it into any of the equations you want. Which one would you like to plug it into? This one? Okay, so if we're plugging it into that one, it's negative 16x plus 2y equals 18. But why did I not write that y beside the 2? Because I know what y is. It's negative 7. So now this equation becomes negative 16x minus 14, because a 2 times negative 7 is a negative 14, equals 18. Now to solve for x, what do I need to do on both sides? Add 14, add 14. So negative 16x equals 32. And now what do I do? So x equals negative 2. Now I'm going to go ahead and tell you. When I check this page to stamp it, or actually I'll just be taking it up since it's not in your packet, if this is all you have on your paper, you're not getting credits. There's no way that you can get these answers without doing some work, so you better have the work shown. I'm letting you know that now so that you don't just sit here and write down the final answers and nothing else. That's fine, you can staple it to it. Well, yeah, I mean, you can come up here and there'll be a stapler to staple it. Okay, can I move on? Okay, let's look at number 2. Number 2, we have 2x. Let me leave a little space. 2x plus 2y equals 9. And then we have 6x plus 6y equals 18. So, if there were a number up there that you could change, what would you change it to and how?
2x and times it by negative 3.
Right. If we multiplied this 2 by negative 3, it would become a negative 6. And then wouldn't that cross out with the positive 6 below it? Okay, so the top equation will become negative 6x minus 6y equals negative 27. I multiplied the negative 3 by all three things in the equation. The bottom equation we're not changing, so we just bring it over. Okay, now we see that our x's both have a 6 and one's negative, one's positive. So we are ready to start adding the equations together. But look what happens when you do that. Negative 6x plus 6x is 0x, but so is negative 6y plus 6y. Everything on this side of the equation cancels out, so therefore it's no solution. Next part, I don't want you to write anything down. I would just like you to watch and soak it in. Okay, William? You're already having problems over there. Okay, be quiet. Okay, I want you just to watch, and I'm hoping that after I do this, you'll have a better understanding. So watch. I'm going to take both of the original equations. Pay attention. 2x plus 2y equals 9. And then the other original equation was 6x plus 6y equals 18. I am going to take each one of them one at a time and rewrite them in slope-intercept form. Y equals mx plus b. Okay? No, you're just watching. This is my mx. It obviously belongs on this side of the equation, so I need to subtract it over there. Pay attention. 2y now equals 9 minus 2x, or we all learned that you can just flip-flop them and put the negative 2x first, since it's your mx, and then the positive 9. Now to finish it out and get y by itself, you divide by 2 on both sides, and those cancel. You end up with y equals negative 1x plus 9 over 2, which you could leave or just change it to a decimal 4.5. Okay, so I have now rewritten this equation in slope-intercept form. I'm going to do the same for this one. There's my mx, so I've got to subtract it to the side it belongs on. Now I have 6y equals 18 minus 6x, or couldn't I just rewrite that? The commutative property says I can flip-flop the order and it's the same thing. Now I divide by 6, and so y equals negative 1x plus 3. What do those two equations have in common now that they're both in slope-intercept form? They both have a slope of negative 1. What do you know about lines that have the same slope? They're not the same line because they start off in two different places. They're parallel. Do parallel lines ever intersect? Well, those are not quite parallel. Do they ever intersect? So therefore, there's no solution because when we graphed them, wasn't the intersection the solution? So that's why this one didn't work out by elimination, because those are two lines that when graphed are parallel. Does that kind of make sense, how it all ties together? Okay, now I want you to take a second and try number 3 by yourself. Okay, for this one, there were two different options. Some of you may have gone the route of changing this 2 to a negative 10, and if you did that, you would have multiplied the top by negative 5. I'm assuming more of you probably decided to multiply the bottom by a positive 5 in order to make that a negative 5x. Either one would have worked, and you all will end up with the same answer. Okay, so if you go this route, your top equation stays the same. Your bottom equation becomes negative 5x plus 50y equals negative 70? Yeah, 70. Okay, so now that we see that we have a variable that has the same number but opposite signs, we're ready to eliminate. They cross out. That becomes 52y. And this becomes negative 52. Now what do we do to both sides? Divide by 52. Which gives you y equals negative 1, and now how can we find the x value? Okay, which equation would y'all like to plug it into? Okay, this one. So 5x plus 2y equals 18, but instead of y, I know what y is, so I'm just going to plug it in. That becomes 5x plus a negative 2, which is just 5x minus 2. And now to solve for x, what do we do on both sides? Add 2, and so 5x equals 20. Now to solve for x, what do we do on both sides? And so x does equal 4. Okay, so those are the final answers. However, if that's all you have on your paper, I'm not taking it up. It's a 0. You have to have all the work.
I accidentally did number 4 instead of number 3.
Well, you can do number 3 later.
No, I just did number 3. But when we were working on
Oh, okay. All right, now let's move on to number 6. Can I erase that, or is anyone still copying? We're good to erase? Okay, number 6.
Why are we skipping number 4? Because I had stuff on.
Let's just move on first, and if we have time, we'll come back.
That's fine.
Number 6, 10x minus 12y equals 4. Shh, pay attention and stop talking. Negative 9x plus 5y equals 8. Okay, with this one, we run into a problem immediately because you can't multiply anything by 9 to make it a 10, and you can't multiply anything by 5 to make it a 12. So what do we have to do in this case? Multiply both. Okay, we have two options. We could multiply by the x's to make them both 90s, or we can multiply to make the y's both 60s. What do y'all prefer? Okay, 90s is probably easier because it's just 9 times 10 and 10 times negative 9, because you need one positive, one negative. So that becomes 90x minus 108y equal to 36. And then the bottom equation becomes negative 90x plus 50y equals 80. Okay, now that we have a variable that has the exact same number but opposite signs, we're ready to eliminate. The 90x and the negative 90x cancel each other out. The negative 108 plus 50 becomes negative 58y, and the 36 plus 80 becomes 116. Now what do I do on both sides? Okay, and when you divide 116 by negative 58, what do you get? Correct, negative 2. Okay, now that we know that y is negative 2, how can we find the x? Shh. Which one do y'all want to plug back into? Okay, so 10x minus 12y equals 4, but instead of y, we now know it's negative 2. So that becomes 10x, that becomes a positive 24, equals 4. Now what should I do? Subtract 24. So 10x equals, and then so x equals negative 2. So those are your two solutions, but that's all the work it takes to get there. Okay, quickly try number 7. Oh, shh. You had two different options for starting this problem. You could have decided to make both of these 10s or make both of these 21s. However, in my opinion, it's easier just to make those 10s because of the fact that one's already positive, one's already negative. These are both negative, so you would have also had to worry about a sign change with that. So we're going to make both of them 10. Well, actually, one 10 and one negative 10 by multiplying that by 2 and that by 5. Is that what you did? And so that becomes 10x minus 14y equals negative 30. And then the bottom one becomes negative 10x minus 15y equals 175. And then those cancel out because 10x plus negative 10x is 0x, so you don't have to write it. Negative 14y plus negative 15y is negative 29y. And then negative 30 plus 175 is 145. Now what would we do to both sides? Divide by negative 29. And so y equals what? Negative 5. Now that we've found y, how do you find x? Right. Which one do y'all prefer to plug back into? Which one? Okay, well, whatever. They'll all work. 5x minus 7y equals negative 15. But y, we now know is negative 5. So this becomes what? Tell me what to write.
9x plus 35 equals negative 15.
Right. Now what do I do next?
Subtract 35.
now I have 5x equals,
-50.
and now what do I do?
Divide by 5.
When you divide negative 50 by 5, you get a
-10.
-10. Okay, once you've written that down, turn to page 13 in your packet. What we did not finish on that worksheet is your homework, but I obviously won't be collecting it until Thursday, so you have 2 nights to get it done.
So we have to do number 5, number 8, number
Is that
10,
13?
And number 4, we didn't do number 4.
13?
Yeah, turn to page 13. Here we go. Yesterday we started learning a method, a procedure for solving word problems. It was known as rules. RULES. What did the R stand for?
read the problem.
Read the problem. Shh. So let's go ahead and read this problem. Michaela and Jenny are selling cookie dough for a school fundraiser. Is it really relevant that they're doing it for a school fundraiser? No. I mean, yeah, you know, they tell us, but that's not really going to help us solve the problem. Customers can buy packages of chocolate chip cookie dough and packages of oatmeal cookie dough. Michaela sold 7 packages of chocolate chip cookie dough and 2 packages of oatmeal cookie dough for a total of $101. Jenny sold 5 packages of chocolate chip cookie dough and 2 packages of oatmeal for a total of $83. Find the cost each of 1 package of chocolate chip cookie dough and 1 package of oatmeal cookie dough. Okay, so we've read the problem. What did the U represent in rules?
Underline the question.
Okay, what is the question they're asking us? The cost, right, the cost of a package of chocolate chip and a package of oatmeal. They want the cost of each. Okay, now we need to line up a plan. Well, to line up a plan, we're going to circle what's important in the problem. What's the first thing you get to that's important?
7 packages.
7 packages of chocolate chip. Okay, those 7 are chocolate, and then 2 were oatmeal, and then that all together made her $101, right? So what 2 variables would you like to use here?
Oh.
How about
C and
C
O.
and O? Just make sure you make your O like a cursive O so you don't get it messed up with a 0. Okay, so how do we represent her selling 7 packages of chocolate chip and 2 packages of oatmeal for a total of 101?
7C plus 2O equals 101.
Very good. Okay, now we need to worry about what Jenny did. What's her important information?
5 packages of chocolate chip.
Okay, so 5C, she did 5 packages of chocolate chip
2 oatmeal.
plus 2 oatmeal for a total of 83. So now from those words, haven't we created a system of equations? Now we just have to solve it, which you should be getting good at by now. Is there anything that will eliminate right away? Not quite. Why not?
They're not negative.
Right. They're both positive. So if we were going to add it right now, wouldn't that become 4O? And we want it to be 0, so what do we have to do? Right. Does it matter which one we multiply by -1? No.
1.
No. No. Look, look, the O's already have a 2 on each one, so we're gonna make the O's the same. We're just gonna multiply this one by a negative, so it'll become a -2, and then you'll have a +2, and then those will cancel out. Okay, so look, this becomes -7C minus 2O equals -101. I multiplied this top equation by -1, and it became that. So now that I've multiplied it by -1, I want to mark it out so that that doesn't confuse me. I'm no longer using that equation. I'm just looking at these. Okay. So now I'm ready to eliminate because my O's have the same number but opposite signs. How many C's do I have when I add these equations? -2C. The O's cancel each other out because when we multiplied one by a negative, it made it possible to cancel. And then what do your constants become? What's 83 minus 101? -18. Okay, now what do we do to both sides to solve for C? Divide by -2. So C equals 9. Tell me in words what C equals 9 means.
The package of chocolate chip cookies dough is $9.
Right, and if you look at your choices, that means it has to be C. We don't even have to worry about plugging that back in to find the cost of oatmeal. It's an automatic null. Now, listen carefully. While the sub is here tomorrow, you're going to be working on more of these word problems. I'm aware that they're multiple choice. You better not just circle an answer for every problem. You better have the work shown. If you can't show it on the paper, put it on scratch paper behind it. Does everybody understand? You can switch out. Don't forget your homework.